Math 100 lesson 7.7 is applications using these rational expressions that we've been working on and using proportions. All right, so these are their word problems. Okay, anytime you see an application, that means we are likely working on some word problems. Okay, so the first type of word problem that we're going to come to is going to be something that deals with motion. And so when things are moving, like in your car, the distance you travel is equal to the rate times the time. So that's what D is. Distance is equal to rate times time. So we're going to be working on some problems that involve distance. Now they're not going to be just simple distance equals rate times time. They're going to be a little more complex. So that's one type of problem. The other type of problem that we're going to be working with is work. And we're going to go ahead and do a motion problem, and then we'll talk about work after that. All right, so there is some setup to this problem, so I will have to, you actually have to write down a word problem, okay? So I'm going to make it as concise as possible. All right. So let's say that we are canoeing. All right, on the Colorado River. All right, so that's what we're doing. We're canoeing on the Colorado River. In still water, your average canoeing rate, which means how fast you are going, okay, your average canoeing rate is 3 miles per hour. All right. It takes you the same amount of time to travel 10 miles downstream with the current, okay, now that's going to change things for us, with the current as 2 miles upstream Since we're going upstream, that means we are now going to be going against the current. So the question here is, what is the rate of the water's current? Since we said we're going to be going with the current or against the current, we're going to need to know what is the rate of the current. Okay, that's the actual question here. Okay, so these do take a little while to set up because we are having to write out the word problem. Apologize for that. Okay, so we're in still water, canoeing rate 3 miles per hour. All right, so we're going to take this information and we are going to put it in a table. All right. Now, I'm going to make a table that has distance equals rate times time. Okay, I'll put my little table up here at the top. Now, the first thing I'm going to put for my distance, let's say we are going downstream. Okay, the distance downstream, it said we went 10 miles, right? Upstream, it said we went 2 miles. All right, so that's what goes there. All right, now let's figure out what the rate is. All right, because we got to put something in there for the rate. Well, here's the thing. The question says, what is the rate of the currents of the water's current? And so what we're going to do is we're going to say let X equal the rate of the water's current. Because that's what we're looking for. We're looking for that, the rate of the water's current. So we're going to let that be x. All right. Well, we know if we're going downstream, we're going with the current. Well, in still water, remember my rate is 3 miles per hour. So 3 miles per hour plus the current's rate. Okay, that's how fast I'm going downstream. Now let's do that upstream. Well, I'm still going 3 miles an hour by myself, but this time I'm going against the current, so I have to subtract whatever the current is. All right. And so the last thing to fill in is that time over there. So I do want to just kind of point something out to you. If I took this equation right here, distance equals rate times time, and I solved it for t. Okay, remember that's what we did the last part of yesterday's lesson. Solve this for t. All right, so d divided by r is t. All right, so over here in my table, I don't know how long it took. All right, but I know it's whatever the distance is divided by the rate. Whatever the distance is divided by the rate. All right, so there's my 2 times. Awesome. Now I've got everything I need in my table. Now, in my little word problem here, it says that it took me the same amount of time. Remember, that's what it says. It took me the same amount of time to go downstream as it did upstream. So what that means is that my 2 times are actually equal. Okay, because it said it took me the same amount of time. So guess what we're going to do? 10 over 3 plus x is equal to 2 over 3 minus x. I now have a rational equation. In section 6, we went over solving rational equations. So now we're going to solve it. All right, so the first step for solving rational equations was find the least common denominator. All right, now I do want to point something out to you. I did say at the beginning of this lesson that we are also working with proportions. A proportion is 2 equal fractions. All right, like A over B is equal to C over D. Okay, like 2 equal fractions. To solve them, to solve a proportion, we don't have to go through all the big steps of least common denominator because it's a proportion. We can multiply A times D, and that's equal to B times C. Now that only works on proportions. That would not work if I had something like 10 over 3 plus x is equal to 2 over 3 minus x plus 6 over 5. Okay, so this only works because this is a proportion that we're looking at. So I'm going to multiply A times D. So 10 times 3 minus x is equal to 2 times 3 plus x. This only works because this is a proportion. All right, so now we just do our algebra here. All right, solving for x. All right, now remember what we got. We said over here, x is the rate of the water's current, and we just found x is 2. So the water's current you can't just say is 2. It's 2 what? It's 2 miles per hour. The water's current is 2 miles per hour. We found it. Okay, so setting up this little table is really going to be helpful to you guys. Now, they're not always going to be equal like our times are here. We do have to pay attention to what our problem says. All right, now that was an example of a motion problem. Now let's do a problem that talks about work being completed. All right, so first type of problem was motion. Now this is a work problem. All right, so this is like saying, I can paint the room in 3 hours. Sarah can paint the room in 2 hours. How long will it take us if we paint the room together? That would be like a work problem. So here's how we do these. We take the fractional part of the job done plus the fractional part of the job done. Okay, because that's 2 people. Sorry. 2 people are working. And when these 2 people get finished working, they have 1 job completed. Okay, when they're done, they have 1 job completed. All right. Okay, so let's make a little bit more sense of that. So x over a plus x over b is equal to 1. This is a plus. All right, so now let's talk about what are x, a, and b. X is the time it takes for person A and person B to complete the job together. Okay, so they're working together. All right, so X would be the time it takes for person A and person B to complete the job together. So A is equal to the time it takes, you guessed it, person A, capital A, to do the job alone. All right, and so little b is going to be the time it takes person B to do the job alone. All right, so we've got X, that's how long it takes them to work together. We've got A, that's how long person A takes to do the job, and then we've got B, that's how long it takes person B to do the job alone. All right, so let's try one of these. Let me give you a problem so we can try to use that. All right, so that's always your work formula, and you just have to decide what goes where. All right, so let me find us one of these. All right. So Amy can paint the house in 8 hours. Mary can do it in 4 hours. Mary's a little faster. How long will it take? I should say how long. Them to do the job together. How long will it take them to do the job together? Okay, so if we're using that little formula I just gave you, all right, we've got x over a plus x over b equals 1. All right, so now here's our question. How long will it take them to do the job together? So let's let x equal time to work together. all right, which is what I already told you x was anyway. All right, so that's how long it's going to take them to work together, x. All right, so x goes here. That's how long it takes them to work together. A is how long it takes person A. So let's say person A is Mary. I'm sorry, Amy. So here's Amy. She is person A. It takes her 8 hours. Mary is person B. It takes her 4 hours. Together, they complete one job. And so now you have a rational equation to solve. All right? So to solve our rational equation, we have to first find our least common denominator. Right? Remember, there is a 1 up under this one. So my least common denominator here is actually an 8. So everything gets multiplied by 8. All right, so I have 8 times x over 8 plus 8 times x over 4 is equal to 8 times 1. And now we actually do the multiplication. All right, I've got common factors, so I'm left with x. 4 goes into 8 twice, so 2 times x, and 8 times 1 is 8. So x plus 2x is 3x. Divide both sides by 3. Okay, now when I do this problem, my math lab is not going to let you put in 8 over 3. It's just not. So some of you are like, oh, okay, I'll just say 2 2/3. Okay, those are 2 2/3 hours. What if my math lab does this to you and it says this many hours, this many minutes, and you have to put something in both boxes? Guess what you cannot do? You cannot put 2/3 in that minutes box. So you got to figure out, what is 2/3 of an hour? All right, what is 2/3 of an hour? 2/3 of an hour. Well, how many minutes are in 1 hour? 60 minutes, right? In math, that little word of means times. All right, so we're going to say 2/3 times 60 minutes. So I'll put a 1 up under there, and now I'm ready to multiply. 3 goes into itself once, it goes into 60 twice, so that is 40 minutes. 2/3 of an hour is 40 minutes. Now, I'm not certain that my math lab does that, but I have seen it before in my math lab, so I just wanted you to be prepared. It might let you type in 2 2/3 hours, but if there is a box for minutes, 2/3 will not work. You must turn that into minutes. Okay, one last type of problem would be something that doesn't have to do with motion or with work. And it doesn't have like a generic equation. All right. So let's say we had a problem that looked something like this. The property tax on a house with an assessed value of $250,000 is $3,500. So that's how much you would pay in property tax if that was your home. Determine the property tax on a house with an assessed value of $420,000. So we got a new house, we upgraded here. assuming the same tax rate. Okay, so the property tax on one house is $3,500. We're looking for the property tax on some other house. This is a great example of using a proportion to solve. So I'm going to create a proportion. Now, a proportion is two fractions that are equal. Now, here's what I'm going to do. I'm going to make a decision before I even get started. I'm going to put property tax in the numerator of both fractions, because if I put it in the numerator of this fraction on the left, it must be in the numerator of the fraction on the right. And then on the denominator of both of them, I'm going to put the value of the home. All right, so now I know what I'm doing. Okay, so the property tax of that first house that we were told was $3,500. The value of that house was $250,000. Okay, that was given to me. We are asked to find the property tax, so I'm going to let P equal the property tax on this house that we're looking for. All right, so P is what I'm looking for this time. The value of this home is $420,000. So I have a proportion. All right, notice property tax over value equals property tax over value. All right. So I told you to solve proportions. We could cross multiply. So 3,500 times 420,000 is equal to 250,000 times P. Big numbers. Okay, so careful when you're writing this down. You want to make sure you get all the zeros. 1, 2, 3, 4, 5, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros. Wowzers, that's a really big number. Okay, and then I divide by that 250,000. Careful when you're typing these numbers in. Room for mistake there. I get 5,880. So that would be the property tax on the house that assessed for $420,000. All right, so that is an example of using a proportion. I do want to make sure that you understand they're going to give you some wildlife problems in My Math Lab in your homework, and you're going to need to use a proportion to solve those wildlife problems. Like they're going to say something about maybe the population of deer the first week and then the population of deer in 6 weeks or something like that. But if you have a question on any of your homework, there's no way I can do an example of every single type of problem. But if you have a question, they're either going to be about motion, they're going to be about work, or you're going to use some sort of proportion to solve your equation, to set up an equation and solve. So just let me know if you've got any questions. You can contact me on email, or we can have a private Teams meeting to discuss any questions that you may have. And this is the last section in Chapter 7. So the next thing you'll be working on after you finish the 7-7 homework will be your review. And so getting ready to take our next test. So let me know if you've got any questions, and I'll see you in our Teams meeting.